Alright, so I think I resolved all technical issues. Now I believe my mic is working well. So I think I'm ready for recording lecture videos. So I tested this mic several times and I realized that, there is some noise. So unfortunately I can't get rid of, but I don't think it is not the level of, intolerance. So hopefully you can accept this noise. I used all functions in the OBS to get rid of this noise, but yeah, it does not work. So I used several functions, installed in the OBS, for example, noise compression and all the other functions, but I can, this is the best, that I can do right now, right? So okay, let me now record the lecture videos. So right, okay, so this is good. Right, so in this first video I would like to introduce basic elements of the framework where we are going to analyze consumers' behavior. Okay, so as I told you in the live lecture yesterday, we are going to go over the consumer theory within 3 weeks. So I guess you already took undergraduate microeconomics, so you're familiar with this classic consumer theory stuff. So I'm gonna go a little bit quickly. So I'll summarize the some fundamental stuffs about consumer theory within 3 weeks. Okay. Right. So our main focus is consumer demand in a market economy, and let me briefly mention a little bit more about the market. So the market in economics is defined as a place where goods or services are transacted at known prices. So let me highlight the word prices. So the key feature of the market is the price of every commodity is publicly quoted, meaning that as soon as you participate in the market, you can observe the current price of every commodity available in the market. Okay. So that exhibits a stark difference from another mechanism, transaction mechanism, that is auction. Okay, so think about the auction. Okay, so even in auctions, transaction occurs between buyers and sellers. A lot of goods or services are transacted via auctions, but they are at some price. But the exercise price in auction is not exogenously given. So as soon as you participate in the auction, you can observe the current price, right? So instead, that price is endogenously determined by individuals' bidding behavior. Okay, so due to that difference, we have to take this auction mechanism as a separate mechanism from the auction from the market. Okay. So the main feature of the market is the known price. Okay? So this is why we call the market as a price mechanism. Okay? So you can easily imagine that consumer and producers will respond to change in price. So in this classic consumer theory, the main question is, how does the consumer respond to change in price? Okay? So we also investigate the other questions like responsiveness to change in income or change in other environments. But the most important thing is a price effect. Okay. So in market, we can put the consumer problem as a choice problem, or more precisely, the problem of choosing the consumption level of each commodity. Okay. So in this market economy, consumer problem is a choice problem of choosing consumption level. Okay. So whenever we describe a market economy, we have to specify the number of commodities available in the market. Okay? So we are going to assume that there are L commodities in this market. So usually in undergraduate microeconomics, we work with a 2-commodity space. That's enough to develop much of a key insights. But in graduate course, we are going to extend that previous toy model to general L-dimensional vector space. Okay? All right, so suppose that there are L commodities, and we come up with a first important notion that is a bundle. Okay, So think about a consumer's choice in this market economy. So given prices at current prices, consumer choose the consumption level of each commodity, and that choice corresponds to L dimensional vector. Okay, so throughout the semester, I'm going to use a bold letters for vectors and typical normal letters for scalars. Okay, so here vector x contains a L different entries, and the first entry x sub 1 stands for the amount of consumption, so the amount of the first commodity consumed. X sub 2, the second entry, the second commodity consumed, and so on. Okay, so a choice corresponds to L dimensional vector x, and this vector x is usually called bundle x. Okay, so bundle can be thought of as a bundle summarizes what consumer intends to do in a market economy. Okay. So what consumer intends to do in a market. All right. In other words, it can be thought of as a complete description of what consumer is willing to do. Okay. In short, it is a complete consumption plan. Complete consumption. Okay. Given the market economy, all right. So in case of L equal to 2, so if you think about a two commodity situation, just as in the undergraduate course, think about a one bundle, say 3,4. Okay, so given this bundle, we can see what exactly this consumer behaves. So what exactly this consumer is going to behave in that market mechanism. Say this consumer is willing to purchase 3 units of good 1, 4 units of good 2. Okay. So given a bundle, we can see what exactly consumer is willing to do in a market mechanism. Okay. All right. So in parallel with this definition, so if we extend so although we are going to focus on static problems, so the consumption choice happens just one time. But if we extend that problem to dynamic problems, so sometimes we are interested in intertemporal choice, especially macroeconomics. So consumption today and consumption tomorrow. Okay, so we are interested in the relationship between these two. Okay, you can easily guess there's a close relationship. So consumption today affects consumption tomorrow. Okay, so in this dynamic problem, so we have not just today but tomorrow. Then a complete. So let me highlight the word complete here. Okay. So in this dynamic problem, a bundle should describe a complete plan. So a bundle should describe what consumer is willing to do today. So we are going to use one more subscript here, time t, okay, time t, and what he is willing to do tomorrow, x sub t plus 1. Okay. So naturally, that's going to be a 2 times L dimensional vector, x sub t. So in case of L commodities, it contains from x sub 1t to x sub lt. Okay, so one consumption plan today, and x sub t plus 1, the other consumption plan for tomorrow, x sub lt plus 1. Okay. So bundle in dynamic problem is going to be 2 times L dimensional vector. Okay. And then we are going to study a choice problem under uncertainty. Suppose that your consumption plan depends on some uncertain events. All right. So for example, you're going to purchase some asset if the stock price goes up, and if the stock price goes down, you are willing to forego that plan. All right. And in order to describe a bundle in that situation, we have to specify what he is willing to do in one possible case and willing to do in the other possible cases. So the associated bundle, it should be what he is willing to do if the stock price goes up. So here U stands for going up, and X sub D. Okay, so that is a basic concept of a bundle. Remember, bundle is a complete consumption plan. Okay, depending on the context. And then the second notion is a consumption set. So usually consumer faces a number of physical constraints in a market economy, and that is captured by, so those physical constraints are captured by consumption set. Okay, and this set is denoted by capital letter X, and that represents the set of all feasible bundles. Okay, so all feasible bundles. So the set of all bundles the consumer can actually choose, in this market. All right. So one standard example of physical constraints is, I think about leisure. So if we think about leisure as a one commodity, okay, but one can't enjoy more than 24 hours per day. So one can enjoy leisure more than 24 hours per day, right? So the consumption set, so if we describe the consumption set in this situation, we have to take off this region, okay, higher than 24, okay. And another example of physical constraint is some goods are, not perfectly divisible, okay. For example, we can't purchase one half of a vehicle, right? So those, those commodities are traded at some, specific discrete units. In such a case, consumption set is going to be, so if good 1 is perfectly divisible and good 2, on the other hand, is not divisible, then consumption set is going to be horizontal line. So consumption set is going to be a horizontal line at each number. So at each integer number, all right? But in most problems, we will work with the simplest consumption set. So, so the consumption set is going to be entire region in the first quadrant. So any bundles can be chosen by the consumer. So any bundles in this region can be chosen by the consumer, okay? All right, so we do not consider, although we do not consider such a physical constraint, we do consider instead one economic constraint, that is the so-called basic constraint, right? So the basic constraint is the set of all affordable bundles, okay? Affordable bundles, okay? So we are going to consider the bundles the consumer can actually choose given his income and given the market prices. All right, so in order to describe about the constraint, we need information about the price vector. So here vector P, okay, this is a bold letter. So this is another vector, it's a collection of so it's a collection of market prices. Okay, so P sub 1, price of a good 1, P sub 2, price of a good 2, and so on. Okay, so in case of two goods, basic constraint can be written as P1 times X1. Okay, so total expenditure on good 1 and P2 times X2, expenditure on good 2. Okay, so there's some, so total expenditure cannot exceed the consumer's disposable income. Okay, so that income will be denoted by W, so it stands for wealth. Okay, so all notations is from the Musgrave Winston Green, so I'm gonna follow that. Okay, so that is a basic constraint in case of two goods. So when L is equal to 2 and its shape is right here. Okay, so the basic constraint budget set is going to be a right triangle in this first quadrant. All right, so and it's horizontal and the vertical intercepts have a nice economic implication. So the horizontal intercept gives us a consumer's real income in terms of good 1, vertical intercept real income in terms of good 2. Okay, And the slope of this budget line, okay, the frontier of this budget set is going to be the relative price, okay, P1 over P2. All right, but in case of L commodities, we can write down the budget constraint using the dot product in a succinct way. Okay, so here the dot product between two vectors. Let me illustrate this dot product a little bit. So if we have two vectors, say two three-dimensional vectors, x is 1, 2, 3, and y is y sub 1, 2, 3. Okay, and the dot product between these two vectors is defined as the sum of component-wise products. Okay, so we multiply component-wise, component by component. So x sub 1 times y sub 1, x2 times y2, and x3 times y3. Okay, and their sum is defined as the dot product, x dot y. Okay, so if we think about the dot product between price vector and one bundle, that stands for the total expenditure, necessary for consuming bundle X. Okay, so that total expenditure cannot exceed the consumer's disposable income. Right? So for every bundle in this set, every bundle in this set is going to be affordable, right? The consumer can choose, can afford, so that is a budget constraint. All right, and then one more thing you can observe is, so budget constraint is a closed set. Okay, so it's a closed. Okay, meaning that it contains the boundary. So it contains all boundary points, all right? So because of this weak inequality, so it contains this budget line, so it is closed set, okay? And also it is a bounded set, okay? And we need one more condition for this boundedness, as long as price factor is greater than 0, okay? So if every good is a not free, okay, then budget set, and then as long as income is a finite number, and that is a natural assumption, right? So in those two, under those two conditions, budget constraint is going to be a bounded set, all right? And one more thing is it is a convex. It is a convex set. Okay. So I'm not sure if you're familiar with this notion of a convex set, but it is quite intuitive. So we say a set X is a convex set. If we choose any 2 points, so X and Y in this set, then its linear combination alpha X 1 minus alpha times Y also is an element of this set. Okay, so it has a nice geometric interpretation. So if we have a set X, okay, this is a set X, then we choose any 2 points X1, we choose 2 points, say X and Y, okay? Then its line segment connecting these 2 points lies in this set, okay? Then set is convex. Otherwise, for example, this one, okay? This is a typical example of a non-convex set, because if we choose these 2 points inside the set, its line segment now, a portion of this line segment is outside of this set, okay? So it's non-convex. All right, so usually if the set is closed and bounded, we say the set is compact. Okay? So, budget set is a compact set. compact. Right? So closed and bounded. All right, and then two underlying assumptions on this constraint. First, the completeness. I already mentioned about this assumption. So in market, the price of each commodity is publicly quoted. Okay, so every participant, every individual in that market economy can observe the current price. Okay? And the second assumption is much more important. Price taking assumption. So price vector P is beyond the control. Okay, beyond the control of each consumer, meaning that although I purchased millions of units of good one, the price of good one is not affected. Okay, P1 is fixed. Okay? So each individual behaves as like a price taker, and that is a key assumption in this consumer theory. Right? So if the market satisfies the second assumption, price taking behavior, we say the market is competitive. Okay? This is a comparative market. All right. So that is a basic constraint, the second basic element in our framework. And the third one, okay, because we attempt to analyze a consumer's behavior. And consumer's behavior naturally depends on consumer's taste. Okay? So in order to describe this taste, we are going to adopt a preference relations. So to define relations, we choose two bundles, bundle X and bundle Y, from the consumption set, meaning that those two bundles are feasible. Okay? And we say X is greater than Y, greater than or equal to Y, using this curly inequality. So what we mean by this curly inequality is the consumer thinks bundle X is at least as good as bundle Y. Okay, so from the perspective of this consumer, bundle X is a slightly better than or equal to bundle Y. Okay, so you can interpret it as a weak inequality. So that is a weak preference. Right, and then using this weak inequality, weak preferences, we can define strict preference and indifference. Okay, so consumer strictly prefers X to Y if so consumer thinks bundle X is at least good as bundle Y, but bundle Y is not as good as bundle X. Okay, and so in that case we can say consumer strictly prefers bundle X to bundle Y. So bundle X is now strictly better than bundle Y. Okay, and then consumer may feel totally indifferent between these two bundles. Okay, and using this weak inequality, we can describe an indifferent situation, that is X is better than Y, and Y is also better than X. Okay. So if these two relations hold, we can say two bundles are totally indifferent to this consumer. All right, and then one more thing is given the preference relation. Okay, so this preference relation represents consumer's taste. So given consumer's taste and one consumption bundle, okay, so we randomly pick up one bundle from the consumption set. Okay, then using these two, we can partition the consumption set into three regions. Okay, first, indifferent set. So that is defined as the set of bundles which are exactly indifferent to the chosen bundle X. Okay, so the set of bundle Y's, those are indifferent to bundle X. Okay, and then upper contour set of X. Okay, so that is defined as the set of bundles who are weakly preferred to bundle X. Okay, bundle X, that is a upper contour set. And the other region is going to be a lower contour set. So lower contour set is the set of bundles. Those are weakly dominated by bundle X. Okay, so now consumer thinks bundle X is better than those bundles in the lower contour set. All right, so from this figure and from this definition, you can easily check indifference set is going to be intersection of these two contour sets. Okay, so indifference set can be defined as intersection of upper contour set and the lower contour set. All right. And if we take a union of these two contour sets, okay, so if we combine these two, and that is going to be the entire consumption set. So union of UC and LC is going to be entire consumption set X. Okay, so hopefully you are familiar with this basic set operations. All right, and then also, you know, although consumer may have a arbitrary preferences, okay, and then that is not observable to, you know, analyst, right? So every consumer has a innate some preference, right? But so although it is a innate and unobservable, we are going to make some assumptions on this preference in order to analyze consumers' behavior. Okay, so we are going to make a minimal structure. So we are going to build up some minimal structure on consumers' behavior. There is a rationality, right? So we say in economic theory, we say preferences are rational if the preferences satisfy these two assumptions, basic assumptions. And the first assumption is completeness. Okay, so we say preferences are complete if for any two bundles, say X and Y, those are feasible. Okay? So we assume that the consumer of our interest is able to tell which one is better. Okay? So X is better than Y, or Y is better than X, or both. Okay, so now that is a indifference case. Okay, so if the consumer can tell either X is better than Y or Y is better than X, or, you know, totally indifferent, right? Then we say his preference is complete. Okay, so that means consumer has a well-defined preference between any two bundles. Right? So one thing you should be careful is, of course, preference can change. So we allow the consumer's preferences to change over time, for example. Okay? For example, I may prefer bundle X to Y today. Okay? So if bundle X is a Korean food and Y is a Chinese food, today I feel like going to Korean restaurant. But tomorrow, you know, this preference ranking may be changed. Okay, I may feel like, you know, going to Chinese restaurant tomorrow, right? That is acceptable. That is allowable. Okay, so that does not violate this completeness, right? Also, in such a dynamic problems, you know, the preference may change, right? But at least today, at least right now, if I tell X is better than Y, I can't tell Y is better than X, right? So that is a you know, basic interpret. So that's the way to interpret this completeness. All right. So it may depend on some uncertain event. All right. So for example, I want to go to Japanese restaurant if the stock price goes up, but if it goes down, so if I'm upset, I may go to Korean restaurant to enjoy some spicy food. Okay. So preference ranking may be changed depending on the some uncertain situations. Once again, does not violate this completeness assumption, right? So at the current situation, completeness requires the individual has a well-defined preferences. Okay. All right, and then the second assumption about this rationality is a transitivity, which is at the heart of this rationality. So it requires, so for now we need a three bundles. If consumer prefers X to Y and prefers Y to Z, okay, And it must be the case, so if the preference is a transitive, the consumer prefers bundle X to bundle Z. Okay? So if this preference ranking is transmitted this way, okay, so precluding any cyclical pattern, so if the consumer prefers Z to X, we have a cyclical pattern like this, right? Then we say preference is a transitive. Okay? So that means individual has a consistent preference, right? We are going to discuss in the live lecture next week how much restrictive each assumption is, okay, by going through the next two examples, right? So, as a matter of fact, for example, completeness, you may take it as some, natural assumption. So it may sound like an innocuous assumption. Sometimes it is not, okay? And so is transitivity, and neither is transitivity. So it is indeed a very strong assumption. Okay. So by discussing these two examples, by going through those two examples, we are going to discuss how restrictive each assumption is. Okay. All right. So this is the first lecture video, and I have a plan for lunch. So I may be able to take one more video, but anyway, I'll see you in the next. All right, so let me briefly summarize what I talked about in this first video. So we talked about the basic elements. So the basic elements of the framework is, the bundle and consumption set and basic constraint and the consumer's preferences. Okay. I also talked about rational preferences. Right. It stems from two assumptions: completeness and transitivity. All right. So hope you enjoyed this video, and I'll see you in the next.